significant figures. When we talk about significant figures, we are talking about numbers where we're stating that they have an actual measured meaning, and it's often easier to look at an example. If I say the population of Canberra is 340,000, I probably don't mean that I've actually counted it and there are exactly 340,000 people and not a single one more. I probably mean I've actually written an approximation, and it's probably, 341,279 or 339,468 or something like that. These zeros, we can't actually be sure that they've been accurately measured. If I put a decimal point here, 340,000 decimal, then I'd be saying we had measured and counted exactly 340,000 and not a single one more or less. But since I haven't got a decimal there, the only numbers I'm pretty sure on are these two. I actually know there's 340,000, and yes, there's some variation in what this 4 could actually be, depending on how we'd round it. But these zeros are not significant. They're just placeholders to get me into the 100,000s. It can be easier to see this if we write it in scientific notation as 3.4 times 10 to the 5. This is all the significant information. The rest of the zeros are just telling us how big it is. The same here. All the significant information is there, and if we write it in scientific notation, 3.78 times 10 to the negative 6, you can see that there's only 3 digits where any meaningful measurement has happened. The rest is just telling us how small this number is. So significant figures are just the numbers that have meaning and aren't just placeholders. Non-zero digits are always significant. And 0 can be significant if it's in between non-zero digits. So this one here, this 0 is significant because for that to be there and other numbers after it, we actually have to know that that's an accurate 0. It's not just that we didn't bother measuring it. 0 digits are significant between other non-zero digits. And they are also significant if they are to the left of a decimal point. But we won't go too much into that. That was, like I said, if I put a decimal point after this, I would be saying, hey, I measured all of those to 0. So this has 3 significant figures, SF. This one has 2 significant figures. So we'll get questions like, state the number of significant figures. Zeros with nothing after them, these aren't significant. 3 significant figures. These zeros, just placeholders, but here's where my significant digits start, so there's 1, 2, 3, 4. And this one, you can easily see it from scientific notation, 2 significant figures. When we're asked to round or write in scientific notation, correct to 3 significant figures, they're saying we only want the biggest 3 digits of accuracy. It's like rounding, really. I don't want this extra bit of information. So, 2.18, 3 significant figures, and just like rounding, check the first thing you cut off if you remove any significant figures. And Make sure that you don't need to round up. It's not 5 or more, so we don't. Times 10 to the 1, 2, 3, 4, 5, 6. So you see how we removed 1 digit of accuracy because we only wanted 3 significant digits. Here, 3 significant figures, we'll start from the largest, means this one, and this one. We'll cut off there, but we will need to round. So this will be 1.95 times 10 to the 1, 2, 3, 4, oops, 1, 2, 3, negative 3. So we're removing some of the accuracy because we don't need it. When you're communicating, if you say the population of Canberra is about 340,000, we've removed some accuracy because we didn't need it. If we were in a situation where we actually needed more accuracy, we'd tell people more information. So it's about convenience and how much accuracy we need.